Screw gauge. Screw gauge is a device incorporating a calibrated screw widely used for accurate measurement of components in mechanical engineering and machining, as well as most mechanical trades, along with other metrological instruments such as dial vernier and digital calipers. Aim to measure diameter of any object using screw gauge. Apparatus. First, screw gauge and second object can be both cylindrical or circular.
Theory. Parallel to the axis of the thimble, a scale graduated in millimeter is engraved. This is called the pith scale. A sleeve is attached to the lead of the screw. The head of the screw has a ratchet which avoids undue tightening of the screw. On the thimble, there is a circular scale known as the head scale, which is divided into 50 or 100 equal parts. When the screw is worked, the sleeves move over the pitch scale. A stud with a plain end surface called the anvil is fixed on the U-frame exactly opposite to the tip of the screw. When the tip of the screw is in contact with the anvil, usually, the zero of the head scale coincides with the zero of the pitch scale. The formula for the same is as follows. Pitch of the screw equals distance moved by the screw upon number of full rotations given. Least count equals pitch of upon total numbers of division of the circular scale.
Procedure. First, determine the pitch and least count of screw gauge using the equation 1 and 2 respectively. Second, bring the anvil and screw in contact with each other and find the zero error. Do it 3 times and record them. If there is no zero, then record zero anvil error and nil. Third, move the screw away from the anvil and place the lead shot, and move the screw towards the anvil using the ratchet head. Stop when the ratchet slips without moving the screw. Fourth, note the number of divisions on the pitch scale that is visible and uncovered by the edge of the cap. The reading N is called the pitch scale reading, PSR. Fifth, note the number of the division of circular scale lying over the reference line. Sixth, repeat steps 4 and 5 after rotating the lead shot by 900 for measuring the diameter in a perpendicular direction. Record the observation in tabular column. 7. Find total reading using the equation 3 and apply zero connection in each case. 8. Take the mean of different values. Observation. Wire. If we take pitch scale reading as 0, we get the circular scale reading as 48 divisions. And then if we multiply the circular scale reading with the least count, we get 0.48 mm. The observed reading comes to be 0.48 mm and the corrected reading is 0.5 mm.
Glass slab. If we take the pitch scale reading as 2 mm, we get the circular scale reading as 66 division, and if we multiply the circular scale reading with the least count, we get 0.66 mm. The observed reading comes to be 2.66 mm and the corrected reading is 2.63 mm.
Lead shot. If we take the pitch scale reading as 3 mm, we get the circular scale reading as 32 divisions. And then if we multiply circular scale reading with the least count, we get 0.32 mm. The observed reading comes to be 3.32 mm and the corrected reading is 3.29 mm.